Let's solve some equations of multiple variables. It's not much different from solving an equation of one variable. We'll treat all the letters as if they were numbers, but they can't combine as readily as numbers can. I'll solve this first one for a, which means that we need to get a alone on a side, and we'll need to move the other variables away from a. So let's subtract both b and c from both sides. Now, some people like to make a line, a vertical line, where their equals sign is to make sure that they are keeping their changes equal. You have to do it to both sides. So I'm going to rewrite the left side as p minus b minus c. They're not like terms, so they have to stay separate. P is positive, and then b and c will be negative. Then let's put our equals in. And we see that here on the right side, our b's will cancel and our c's will cancel, but that was the goal. We wanted to get the a alone. So there's our answer. A equals p minus b minus c. If we want to solve f equals ma for the variable a, we'll just want to do a division to get the m away from the a. But let's do it equally on both sides. The m's will cancel on the right, leaving behind just a. Bring our equals down. And we'll have f over m on the left. And it's solved. How about if we want to isolate the variable w here? Well, there's multiplication and addition. We have to undo the addition first. This is going to give us p minus 2l on the left. And we'll have 2w on the right. Now we can divide by that too. But we do have to do it on all terms. That way it's fair. We did it to the whole side on the right, so we have to do it to the whole side on the left. And then we can rewrite our results. And that could be a good final answer. Notice that we can't really cancel the 2 here because the p doesn't have a 2 to cancel with. Let's solve this formula for h. First thing I might do is get rid of the fraction. Now, in order to get rid of a fraction, we should multiply by the fraction's reciprocal. That's the same fraction but flipped. This will cause the 2's here to cancel, but we have to do it equally on both sides. That'll leave us with a 2a on the left and a bh on the right. To get h alone, we'll divide by b. And we'll have 2a over b equals h as our final answer. Okay. Solve this equation for y. I'm going to move the 2x first. We'll have this. And now we want to get rid of the negative 4. Let's do it to all sides. Okay, that's pretty good there. But technically in math, we don't want the denominator to have a negative in it. It's not considered simplified. So instead, we're going to make a change. Let's switch the denominator's sign to positive. But if we do, then we have to switch the sign of every other term as well. And that would be fine. So negative 3z plus 2x over 4 equals y. That could be a good answer. And our last one here. We want to isolate f. There's a lot of things happening to f. He's being subtracted. Let's see, there's a subtraction of 32. There is a multiplication of a fraction here. You got to figure out which one to undo first. Now, according to PEMDAS, when we're solving equations, we go this way. So additions and subtractions normally get undone first. But this subtraction is in parentheses. Parentheses get undone last. So the first thing to undo here is actually the 5/9. Okay, so let's go ahead and multiply by the reciprocal of 5/9, which is 9/5. As you can see, the 9's here will cancel, and so will the 5's. That'll leave us with 9/5 c equals f minus 32. So the 5/9 is gone. Now the way that you get rid of parentheses in an equation is you get them alone. If you get the parentheses to be the only thing on the side, then it doesn't matter whether they're there or not. Now they're gone. And we'll do the last step, which is to add that 32. Nine-fifths c plus 32 is f. And that will be our final answer.